So lots of different things about functions today, definition, what are we talking about when something is a function, how do we test for that, what are we talking about with domain and range of functions. So the best place to start is with some of the vocabulary. A function means we have some kind of a rule that takes each element of the domain or each input and matches it to exactly one element of the range or the output. So each input has exactly one output. Sometimes it will be given to us as a function rule. Sometimes it will be given to us as a list of ordered pairs. So if each input has exactly one output, that means we cannot have something with a first coordinate and no output. That doesn't work. It also means every time I have, for example, 1 as the input, I get one and only one possible y that goes with that. So if my x is ever repeated, my y has to be exactly the same in every one of those ordered pairs that had that repeat x as the first coordinate. Sometimes we will also have them given to us as a graph. Remember the vertical line test from past years for functions? If we have our graph, any place we want to put a vertical line, it can only cross that graph one time. If it ever crosses in two places, that means we have points above and below each other that would have the same x coordinate, but one y would be bigger than the other y, so that would not work. It would be one x with two different y's. Sometimes we will do mappings, which means we have an oval on the left with some numbers in it for the domain, for our inputs, and we have another oval over on the left with numbers in it, and those will be all of the outputs or the range, and we have arrows saying this input goes to this other output. So far so good, seeming familiar from other years? Okay, domain is going to be all of the things that we allow for the independent variable for the input, generally speaking x's. We're going to talk about a couple of restrictions here in a few minutes, so just leave some spaces in your notes to fill that in a little bit. And then range will simply be all of the outputs that we allow for a given function. So all of the outputs, the y's, the dependent variables. And then one vocabulary term that is a little bit new, one-to-one. It has to be a function first. So it has to pass the vertical line test or these other descriptions of what it takes to be a function. Then it is one-to-one if not just each x has exactly one y, but if it's also true each y came from exactly one x. So if we have ordered pairs, not only can the x's not repeat, the y's can't repeat either unless both coordinates are exactly the same. If it's a graph, it has to pass the vertical line test to be a function and pass a horizontal line test to be one-to-one. If it comes from a mapping, all of the arrows have to go just from one thing to another. Nothing that has two arrows starting or ending at that particular value. And that will be one-to-one. So I'm next going to go through some examples with you of vertical and horizontal line tests and of some sample functions, questions that will be just like what you'll see in different problem sets, and I can walk through exactly what I'm asking you to write down, what you're looking for, how you verify it or not. Now, a couple of you still finishing up your writing, and then we'll move on to those next slides. Vertical line test. We're given functions. So say the green function on the left. To pass the vertical line test, I've got two vertical lines up there, but it would mean no matter where we would put it, is there ever a place where we could draw a vertical line and it would touch that green function more than once? No matter where we put it, it's only once, so that one is a function. Then if I look at the black circle, I could put a vertical line where I have this one on the left and it just touches one time, that's fine. I could move that line and now it touches 0 times, that's fine. But there are also a whole bunch of places where I could put a vertical line and it goes through the circle twice. So for example, these 2 points right here would both have an x-coordinate, in this case of 2, but they'd have different y's. So this one is therefore not a function. So far, so good? Now let's throw the horizontal line test in, since that's new this year. It has to be a function, so it has to pass the vertical line test. Does it look like the green and the blue ones would both pass the vertical line test and be functions? So yes, these are both functions. And for this one on the left, if I can get my line to cooperate, and it does not seem to want to, so we'll just imagine if we put a horizontal line any old place, is there ever a place we could draw it where it touches that more than once? Looks like the green part's almost horizontal here, but it's still just barely vertical, so we're still just going through one time. So this one passes horizontal and vertical line tests, so it is a one-to-one function. What about the one on the right? Does that horizontal line go through more than once? So where it is right now means it fails. Doesn't matter that it's okay here where it only touches once or here where it touches 0, because there are places where it would cross twice. This one is a function, but not one-to-one. Okay, this is what problems in the book are going to look like. Are they functions? Are they one-to-one? Anytime you say not function or not one-to-one, I need you to write me a reason. And so we're going to model what that would look like. For this one, let's just go through first and talk about function. Then we'll go back through them and worry about one-to-one. So for A, it's a list of ordered pairs. So to decide if it's a function, I'm looking for, are there any x's that repeat? Do any of those x's repeat? So yes, thumbs up, no, thumbs down. Is it a function? So you are correct. That one is a function. We'll worry about one-to-one in a few minutes. For B, do I have any x's that repeat? Do they have different y's? So these two have the same x but different y's. So does that mean function or not function? So we are going to write down that B is not a function. Since it's not, we have to give a reason. And the reason is the input 1, we're going to be specific, has 2 different outputs. So I'm going to name them outputs 2 and 3. So I've written down which input has what different outputs. C, any x's that repeat? But do those x's have the same or different y's? So that is okay. Every time x is 4, every time the input's 4, the output is 3. So C is still a function. And what about D? Do I have any x's that repeat? No x's that repeat, so function or not a function? So that one is a function. So now we're going to go back and worry about the one-to-one part. So for A, now we're looking, are there any y's that repeat? So that means each y just has exactly one input. So that means it is also 1 to 1. Okay, skip B because it was not even a function, or it was not a function. C, do we have any y's that repeat? Do they have the same or different x's? So thumbs up, thumbs down, 1 to 1 or not? And that's correct. It is not 1 to 1. And then the reason is going to be that the output 3 had 2 different inputs, and we'll name them. So inputs of 3 and 4. Finally, for this one, let's take a look at D. Do we have any y's that repeat? Same or different x's? 1 to 1 or not? Thumbs up, thumbs down. So it is not 1 to 1. And the output of -1 had different inputs. In this case, it had 3 different ones of -1, 1, and 4. So questions when it's listed as an ordered pair, how you figure out if it's a function, how you figure out if it's 1 to 1, and what I'm looking for. This one will model with the mapping diagrams. So for A, that means we have the point 4, 3 and the point 3, 3. So as we look at A, thumbs up, thumbs down, function or not function? So that one is a function. Shortcut way, there's nothing in the input box that has more than 1 arrow attached to that value. What about 1 to 1? Thumbs up, thumbs down. And you're correct, it is not 1 to 1 because the output of 3 has the inputs 3 and 4. So when we had 2 arrows at the same output value, that meant not 1 to 1. Okay, B, function or not function? Thumbs up, thumbs down. Function, not, come on, let me see, everybody. Okay, that one is not a function. And the reason is 5 has 2 different outputs. And those outputs are 3 and 4. Let me move this so you can see. C is a little bit tricky. What do you think about C? Function, not function. Let me see those thumbs up, thumbs down. Okay, you are correct. C is not a function. Who can tell me why not? This reason's a little bit different. Hope. Exactly. The input of M has no output. And our definition of a function was that each input has exactly 1, and 0 is not exactly 1. Okay, D is a little bit different, so I want us to make sure we talk about that and understand a couple of ways to think about it. For D, the domain is all of the real numbers. Is it possible to write down all of the real numbers? That's why we don't have that oval with a whole bunch of numbers in it. We just say all of the real numbers. So we then have a rule for how we get to the outputs. So the rule is you take a real number and you add 2. Is there anything that you don't have a defined answer for? Is there any real number you can't add 2 to? So every real number is going to have an output. If you pick one real number, are there ever 2 correct answers when you add 2? So it's going to have exactly 1 output. So it is going to be a function. If we go backwards, so we have our answers over here that were real numbers. They came from something that was 2 smaller. So if we take things in our outputs and subtract 2, is there ever more than 1 correct answer? So it is going to be 1 to 1. Now sometimes when they give you the rule, it may be easier to think about the graph. Do you know how to graph y equals x plus 2? You better. Straight line, but that's not enough to just say straight line. Could be horizontal or vertical. So it is going to be the line that has y-intercept of 2 and a slope of positive 1. Does that pass horizontal and vertical line tests? So we could also draw the graph and say passes horizontal vertical line tests. Questions? Oh. Yeah, you could have a circle rule. You could or you could have a parabola rule. It would be a function, but not one-to-one. That's probably what you'd see more at this level. Y equals x squared, and it would be a function, but it would not be one-to-one. Okay, these we'll just do by thinking about the graphs. So to go through them a little bit faster, thumbs up, thumbs down. A, function, not function. Okay, not function is correct, and we have to give a reason, which is when we have the graph, that it fails the vertical line test. If it's not a function, we don't worry about one-to-one. B, function, one-to-one. Excuse me. So it is a function, and it is one-to-one. It passes both vertical and horizontal line tests. Now, before you tell me about C, I need to remind you this open circle means that point on the end is not actually on the graph. That's just showing you that's where the end point is. The filled-in circle means that is actually a point that is part of the graph. So for this one, for the vertical line test, is there any vertical line that goes through 2 or more points on the graph? So is it a function or not? Thumbs up, thumbs down. So this one is a function. If we did our vertical line right there, it would go through that top point, but that bottom one is not a point on the graph, so we're fine. What about one-to-one? It is not one-to-one because it fails the horizontal line test. We could put it either here or here, and it would fail that test. And the final one of these, what about the last one? Function or not a function? It is not a function. And if we were to put a vertical line right here, it would go through 2 points. So it fails the vertical line test. So I've tried to model the kinds of things that you may be asked on those types of homework problems. Everybody good so far? All right, I need you to really tune in on this next part. This is the part that students find the most confusing. So everybody, really tune in right now on this. The restrictions on the domain. So one thing we have to worry about is we cannot divide by 0. So that means we have to look, are there any denominators? And we need to make sure that those denominators are not equal to 0. So what I will do on these is I will look for any denominators in the problem, copy them down exactly like they are, and say that denominator cannot be 0. Then I'll go through the algebra steps to get x not equal to. And I want to see that work on anything that has a denominator, and it's asking you about the domain. The second restriction, we cannot take square roots of negative numbers. We're talking about graphs. So we have an x and a y axis. Those are only real numbers. We don't know how to put any complex numbers on the x-axis or on the y-axis. So we cannot have any negatives inside the square roots. So what we're going to do is to take the radicand, which is whatever is inside the square root sign, and write down that it can't be negative. In other words, it must be positive, bigger than 0, or equal to 0. We're going to write that down just like that, and then we're going to go through the algebra steps until we have x is greater than or equal or less than or equal to something. And then we will know our restrictions on the domain. As soon as we finish writing, we're going to do a couple of examples on that. So you will have homework problems that say, find the domain of different functions. So every single time you are going to look for denominators and square roots. Some won't have either one. There's nothing to worry about. Some will have just one. Some will have both. Does this one have a denominator? What is the denominator? So we write it down. What do we worry about with denominators? They can't be 0, so we write it down. Don't do any steps in your head. Write the denominator down exactly as it shows up, not equal to 0. Show the algebra, so subtract 3 from both sides, and we have x is not equal to -3. Does this one have any square roots? So there's nothing more to worry about. So now we're going to write down our domain, capital D equals. This is what we call set builder notation. Squiggly brace, not a parentheses, not a square bracket. It must be the squiggly kind. Domain is x's, and they first off have to be real numbers. So x is an element of the set of real numbers. Then we do one vertical line, which means such that. There's not going to be another one over on the right-hand side like for an absolute value sign. There's just one straight up and down for such that. Then we write down our restrictions, starting with x is not equal to -3, and that is our answer. When we write these restrictions, they will always be such that x is not equal to something, or x is bigger than, or greater than or equal to, or less than or equal. It'll always start with x, or we'll have some number and a second number, and we'll do the smallest one, and then x, and then the biggest one, so number line order, with the less than or equal signs in between. Okay, next one. This one is talking about function notation. It wants us to evaluate f of 2. So that means we have a rule for a function named f. If we change this x to a 2, we change every x in the formula, in the rule, to a 2. So f of 2 is square root of 4 minus 2, square root of 4 minus 2, so square root of 2. So that's easy, right? Now we want to find the domain of f, so we're going back to this original rule. F of x is the square root of 4 minus x. Do we have any denominators? So nothing to worry about with denominators. Do we have any square roots? So we write down the inside part, the radicand, which is 4 minus x. What do we worry about with square roots? It can't be negative, which means it has to be positive or 0. Now we're going to do the algebra. Now, I could subtract 4 from both sides and have minus x is greater than or equal to -4, but then when I multiply by the -1, I have to remember to turn that sign around. I personally do better if I think of it as I'm going to add x to both sides. So I have 4 is greater than or equal to x, and then I'm going to turn it around so my restriction can start with x. If 4 is bigger than x, that means x is smaller than 4, so x is less than or equal to 4. So this time my domain is all of the x's that are real numbers such that x is less than or equal to 4. Just a couple more things to cover with you. So it's all about functions, but they throw a lot of different ways of talking about it at you in this lesson. They may also give you graphs and say, find not just the domain, but the domain and the range. So we're looking for, are there any restrictions, smallest and biggest x's, smallest and biggest y's? So for A, for the domain, we're looking for the x's, so we start our set builder notation like that. And then we're going to say, is there a smallest x? So let's see, if I'm looking for my x's, right there's my smallest one, right? Negative 10 is my smallest. X is in the middle. And do I have a biggest one? And can I get back to being able to move this line? Maybe let me grab it here. Okay, do I have a biggest one? Still have bigger ones. That's my biggest. And so I look at that, and that's 10, 9, 8, 7, 6, 5. Now, did I actually have an X that was negative 10? Yes. This end is colored in, so negative 10 was less than or equal to X. Do I actually have one that's 5? No. So just less than. So number line order, negative 10 to positive 5, X is in the middle. Does that part make sense? All right, let me move that over here for the next one. Now for the range. First thing to be careful about, range is Y's, not X's. So when we do this set builder, it must start with Y. And now we're looking for smallest and biggest Y. So Shane, help me out here. Do I have a smallest Y? Is that the lowest point on my graph? And what would that value be? Y is what? Negative 9. And that happened to be at one endpoint. Is the other endpoint my biggest Y? Is that the highest point on my graph? So it's not necessarily endpoints on these. Up here is my highest Y, 10, 9, 8, 7. So my Y's went from negative 9 to positive 7. Open circle is negative 9, so negative 9 is less than Y, because range is the Y's. And I do actually have a point right there with a Y coordinate of 7, so I include the or equal to. Little twist with this last graph. Let me take that. Do I have a smallest X? Why not? Okay, that arrow means it keeps going, so I do not actually have a smallest X. Do I have a biggest X?
Yes.
Which would be what? 8. And so X has to be smaller than 8, right? So I can say for this one, the domain is all of the X's that are real numbers such that, and I'm going to start with X, X must be smaller than 8. 8 was not actually included. That was an open circle. Y's. Do I have a smallest Y on this graph? And how small is my smallest Y? What's my lowest point? Negative 4. Do I have a biggest Y? So I only have a smallest Y. The Y has to be above negative 4. So Y has to be above negative 4. I do actually have a point with a Y coordinate of negative 4, so or equal to. And then one last thing, which is combining function notation with your right triangle trig. So we can do h of 30 degrees and have a function rule like this one that we have. This simply means we're going to put a 30 degrees in the parentheses, so we're going to change that theta to 30 degrees. So we change every other theta to a 30 degrees. So h of 30 degrees is 6 cosine 30 degrees. So we've got to draw that 30, 60, 90 reference triangle. Make sure it looks like it has a long leg and a short leg. Label the angles. And help me out here. This side over here on the left is how long? And the hypotenuse is? And the long leg? Cosine is what over what? Adjacent over hypotenuse. So we're 3 over 2 that gets multiplied by 6, so that we have 3 root 3. Questions from anybody? Okay, we don't have a lot of time left. I would like for you to start with number 9 which is finding these domains. What are the restrictions that you have to worry about? I won't have time to check individually, but we'll get some stuff up on the board here to kind of help you with that in a few minutes.